All right, so in this lesson, we're going to talk about how to find the distance between points. And the first thing we're going to do is look at points on a number line, and then we're going to switch over to finding the distance between points on a coordinate plane. So there's a lot of different ways we could go about doing this. Here is 12. Here is -4. Obviously, one of the ways you could find the distance between them is by actually counting. Another way you could do this is a distance of 12. This is a distance of 4. Adding them together gives me 16. You could also think of this as a positive distance of 4. So 12 plus 4 more gives me 16. You could also think 12 and then minus -4, which would also give me that 12 plus 4. But either way you think about it, the space here shown between 12 and -4 is 16 units total. So the next thing we're going to do is we're going to look at this problem with a boat. So 2 boats are leaving the same marina. So before I even go any further, I'm going to start drawing a picture. So here is the marina, and I'm going to label that point M. One boat heads north. So here's boat number 1. And then the other boat heads east, which is straight to the right. So here's boat number 2. So after some time, the northbound boat has traveled 12 miles. So I know that this distance here is 12 miles. And the second boat has traveled 16 miles. So I know that this is 16 miles. And my goal is to figure out how far apart the 2 boats actually are. Well, that's this distance here on the diagonal. This is what I don't know, and I'm going to label that D for distance. Now, since they went directly north and directly east, I know that they created a right angle here at the marina when my document camera unfreezes. There it is. So since I have a right triangle here, I know that this was beaten into your heads when you were in middle school. If I have 2 legs of a right triangle and I'm trying to find the hypotenuse, I can use Pythagorean theorem. There it is. All right, so it does not matter what we choose to put for A and what we choose to put for B. So I'm just going to do 12 squared plus 16 squared, and that's going to be this hypotenuse D that we're trying to find, this distance. So 12 squared is 144. 16 squared is 256. And today is the day that I am going to allow you to start using a calculator. So I'm going to just travel back up. I'm going to start doing some work over here. So I have 400 being equal to D squared. Now, if I want to know what number squared gives me 400, what I can do is take the square root of 400, because square root is the opposite or inverse operation of squaring. So if I take the square root of D squared, what I'm going to be left with is just D. And then if I take the square root of 400, that gives me 20. So this tells me that the boats are 20 miles apart. So I'm going to take this idea of what we just did with this right triangle, and we're going to apply it now to a coordinate plane. So I have the points 5, -2, and -6, 4. So here is A. And here is B. And my goal, I thought I had my ruler close by. My goal is to find the distance or the straight line that connects points A and B. So what we're going to do is create a right triangle using points A and B. And if I force a right triangle to appear on my graph, what I can do is use Pythagorean theorem. So I need to figure out how far it is on the horizontal leg and how far it is on the vertical leg. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then this will be 1, 2, 3, 4, 5, 6. And then ultimately, my goal is to find the distance here between those 2 points. So what I'm doing is 6 squared plus 11 squared gives me D squared. Well, 6 squared is 36. 11 squared is 121. So 121 plus 36 is 157. And then I am actually using my calculator. If you have an iPhone, you can turn this calculator sideways. I'm going to type in 157 and then hit the square root button, and it tells me exactly what this is for D. So you have 2 options here. If it's a multiple choice question, you could see it as the square root of 157. Or if it's a rounded decimal answer, you could also see 12.53 if we're doing 2 decimal places. And yet again, my calculator has decided. Okay, there we go. So we're going to do one more, just like that, where I give you 2 points on a graph, and we're going to find the distance between them. So I have -2, -3, and this is point B. And then -8, 1, 2, 3, 4, 5, wait, 2, 4, 6, 8. There's point A. Okay. So this triangle is smaller than our last one. So my D value here on my hypotenuse should be smaller. Now, it does not matter if you do your triangle down or up. I'm going to do mine up to show you that there's no difference, because ultimately we're still using those 2 points there to create this right triangle. So this is 3, and this is 6. So I have 3 squared plus 6 squared equals D squared. So this is 9 and 36. being d squared, which gives me 45. Taking the square root of both sides tells me that d is either going to be written as the square root of 45 or 6.71. Now there's another calculator that you have access to as an app on your phone. It's the Desmos Scientific app. This is what the app looks like when you're going to download it. It's the same company that made our graphing calculator, Desmos, that I know we haven't used yet, but hopefully you've heard me talk about. So if you download this scientific app, it looks a little bit different than your calculator from your phone regularly, but we have more functions available to us on here that are easier to access. So if I'm going to do it in my Desmos calculator app, I hit the square root button first and then type in 45, and then it will tell me my answer here. Now you can also do 3 squared plus 6 squared in your calculator without having to do them separately. You don't have this option in your other graph or the app that's just the calculator on your phone anyway. So personally, I always use the Desmos app just because it's more user-friendly and I have more functions available to me. So after I did that, then I could type in the square root of 45 and still get my answer. There is a formula that we could use where we wouldn't have to count. Personally, I do not care if you choose to memorize this or not. Personally, because we have so many other formulas that we need to keep track of in our brains, I would not memorize this formula. But again, it's up to you. So what we're doing, since I have 2 different x values and 2 different y values, I can actually just use those x and y values directly, to find the horizontal distance and the vertical distance. So if I look here at 6, that's my horizontal distance. So that means this 6 comes from the x values. So if I look here between -2 and -8, well, if I did -2 minus -8, that would give me 6. Same thing here. If I took -3 and subtracted -6, that would give me 3. So that's how I would get 3 and 6 right from these coordinate points. So in general, and again, you do not have to memorize this. If you are comfortable doing the Pythagorean theorem from the right triangle like I did in the other 2 questions, then that's exactly how I want you to do it. And I don't want you to even bother with this formula, okay? But what we did in order to find our distance is I took the square root of the difference in my x values squared, and I added that to the difference in my y values squared. Now again, I do not care if you choose to do this or not. You could do it step by step. If you did it step by step, what we would do first is I would do x1 minus x2, and I would make sure that this was positive because I want my distance to be positive. Distance can never be negative. And then I would do the same thing with my y values and make sure it's positive. So this is our horizontal distance, and this is our vertical distance. I take that number and I square each number, So we square each distance, and then I add them together, and then I take the square root. Like I said, if you're comfortable with how I did it with the right triangles on both of those examples, then do that every single time. Pretend that we didn't even do this and completely ignore that formula if you feel good with the other ones. If you see this formula and you're like, oh, that totally makes sense, I get it, then by all means, feel free to use the formula. But typically, this is more user-friendly, and most people will choose to do this method where we're just counting on the coordinate plane.